Hi, pre-calculus students. This video is just to go over the basics of describing domains and ranges for functions. We're going to look at two different types. We'll be looking at discrete situations where we have tables, mappings, plotted points, that sort of thing, and then we'll look at how to describe them for continuous functions. So we'll start off here with the discrete cases. We have a few examples here just to look at. So first of all, just a domain or a range at its simplest level is just a list. We're looking for a list of values that are possible inputs and possible outputs respectively. So all of the possible inputs would be described as the domain. All of the possible outputs are described as the range. So when you're dealing with a discrete function, it's possible to just write them out and actually make that list. And so, for example, for the domain for these functions here, for you, if you have a table of values, you're just going to list out all of the input values of the table. So in this case, that's probably going to be the t here because it's listed first. So the list of your domain would just be the values 2, 5, 7, and 9. If you're looking at a mapping, you're just looking at the area of the map registered as the input, which is where all the arrows are originating from. So for a mapping like this, the domain would just be the list -3, -2, 5, 7. If you're looking at a set of ordered pairs or plotted points on a coordinate plane, you're just finding the x coordinates of the points and listing out all of the x coordinates. And then for the range, it's just the same idea, just with the outputs or the y coordinates. So you'd be looking at the list 3, 1, 5, 4, 6, 8, 5, 9 here. Notice in particular, and this is true for both the domain and the range, if any values are repeated, or actually I should say just the range, right? Because you can't repeat values for the domain of a function. If any values are repeated in the range, we don't have to list it multiple times. So for example, in this one here, the 5 is repeated, but we would just say the range is just 1, 3, and 5. We don't have to indicate that there was a repeat there. So for equations, for a linear equation like this, you're probably comfortable saying that the domain is all real numbers and the range is all real numbers. But we're going to start looking at more complicated functions and analyzing some of the restrictions that are there and describing what those are more formally here in pre-calculus. So we're going to look at that next for more continuous functions. Before we look at an example, though, I want to go over a couple of guidelines to guide your thinking through for these functions. So when we're talking about the domain of a function in particular, really what we're thinking about is the answer to the question, and is there any number that cannot be an input into this equation? So if you're looking at the equation and I'm asking you for the domain, that's the question that you want to be thinking about. Are there any numbers that are not allowed? So there are lots of reasons why a number would not be allowed an allowable input into a function. The two that you're probably familiar with from Algebra 2, and we're going to look at others later on over the course of the year, but the two that I expect you to know and just be familiar with from Algebra 2 are these two mathematical rules. So number one, we can't square root a negative number. That would give us an imaginary output. Um, those are valid things. There are valid areas of mathematics that deal with those, but we're not going to be worrying about that in pre-calculus. We're only going to be dealing with the real numbers, and so we can't allow any negative inputs into a square root function. And then the other rule is that we can't divide by zero. So those are the two things that are the two rules that we need to keep in mind. Any values that would cause either one of these things to happen, either a square rooting of a negative or division by zero, would not be allowed, and we would have to restrict those out of the domain. So kind of a good general guideline to start out is you start out under the assumption that you have a domain of all real numbers, and then you look for values that cause you to divide by zero. We'll cut those values out of the domain. Look for any values that would make a square root of a negative, cut those out of your domain, and whatever else is left is going to be the domain for your function. So I'm running out of time for this video, so I'm going to stop it and we'll look at an example on the next video.